Yes, the Science and Technology Department at the International Commission on Missing Persons seeks to employ the principles of forensic science in the location, recovery, and identification of missing persons. Uh, this applies to living missing people who may be reunited by DNA identification, for example, a missing child. But in many instances, it relates to unidentified human remains as a result of, say, mass disasters or post-conflict mass graves and that kind of thing. And these principles of forensic science are used to robustly and scientifically provide an accounting of the fate of the missing person. Particularly DNA identification methods are applied that offer scientific certainty with regard to human identification when properly combined with all the evidence in the case. So indeed, it is a multidisciplinary approach, but most of the time underpinned by the certainty of DNA identification. In day-to-day work, one of the principal challenges is that the DNA is highly degraded or broken down by environment or microorganisms, and therefore we have to use highly exacting techniques to recover the few remaining DNA molecules in order to generate a DNA profile. A second key limitation with regard to DNA identification of missing persons is the need for multiple close relatives, family members of the missing, to whom comparisons can be made. And with current technology that's widely used around the world, very often you need multiple first or second degree relatives, that is to say, parents or siblings or constellations of other close relatives in order to make an identification. Yeah, another challenge in many contexts is simply locating the missing people if they happen to be dead, finding sites where their bodies have been disposed maybe decades ago that could be covered with vegetation and that kind of thing. So we're turning increasingly toward modern methods involving things like satellite imagery, or we're developing programs where we hope to use multispectral analysis to discover grave sites in ways that previously were not possible. With regard to those two limitations, that is to say, degraded or vanishingly small quantities of DNA from the samples and the necessity for multiple close relatives to make an identification, we're now turning to what is known as next-generation sequencing techniques or massively parallel sequencing techniques. In an assay that we're developing at the ICMP, we now look at many DNA locations in the genome, far many than are typically used. And this allows us to do two things. One, to identify individuals when there's even a single distant family member as a relative, for example, a first cousin. And secondly, by the nature of this test, which focuses on very small fragments of DNA, we're able to get useful, powerful DNA profiles from even more highly degraded samples. So this combination of advantages really will serve to, I think, push forward the frontier of what's possible in DNA identification. So having spoken about the DNA identification component of things, we also have to consider the challenges with regard to the recovery and location of human remains. So the ICMP is working with informatics systems to locate both family members of the missing as well as clandestine locations where bodies may be recovered. Once that's been achieved, it's very important to employ courtroom quality scene of crime operations in the recovery of human remains in a way that both preserves evidence and also allows for makes maximum allowance for the identification of those bodies down the road.